Good morning, everyone. I'm actually waiting for you to settle. So, yesterday we discussed and calculated how you can ascertain the amount of power consumed in your house. And the outstanding fact was that the longer you use your appliances, the more you shall pay for your power consumption. Also, what you need to remember is that you have to consider the diversity factor. As discussed earlier, in order to use power sparingly. Today we want to determine why we protect a cooker at 30 or 32 amps, or at a circuit breaker rated 30 or 32 amps. And this we shall realize just by calculating the current rating of an electric cooker as given on its specification plate. Example 1. A cooker unit has a full load rating of 12 kilowatts at 240 volts. Calculate the current rating of the cooker if the cooker has a socket outlet embedded on it. So remember, we've been given the full load rating of the cooker. So the full load rating of the cooker here is 12 kilowatts and the voltage is at 240 volts. Remember, 1 kilowatt is equivalent to 1,000 watts. So first we need to convert 12 kilowatt, the rating of the cooker, to watts. So that will be 12 times 1,000. That will be 12,000 watts if converted into watts. So power is equal to current times voltage. So that is P is equal to IV. So in this case we have been given power as 12,000 watts. That's the rating of the cooker, and voltage is 240. So we already have power and you have voltage. So what is lacking is the current. So by formulating, we'll have I as P over V. That is power over voltage. So we are going to have 12,000, which is power, over voltage, which is 240. That one, if you divide, will give us 50 amps. Our first equation is take the first 10 amps. So we are going to subtract 10 amps from 50 amps. So we are going to have 40 amps. That's the first equation. Second equation is that calculate 30% of the remainder. So we are going to calculate 30% of the remainder. That is 30% of 40, because from 50 we are going to subtract 10, so we are going to remain with 40. So you calculate 30% of the remainder, that is 30% of 40. So if you do that, you are going to have 12 amps. The third equation is add 5 amps if a socket outlet is embedded to that cooker unit. But remember, the cooker units we mostly use in Kenya as the cooker socket embedded on a socket outlet embedded on them. So for us to determine this, we are going to add all the three equations together. So we are going to have the first 10 amps, so that is 10 plus 30% of the remainder, that will be 12 amps, plus 5 amps because the cooker has a socket outlet embedded on it. So if you add those, it will give you a total of about 27 amps. So if a cooker is rated 12 kilowatts at the supply voltage is 240 volts, then this cooker need to be protected at 30 or 32 amps because its consumption is below 30 amps. You cannot protect a cooker as 20 amps as some people does, because its consumption is much higher than the protection you're going to give it. So you're supposed to use a circuit breaker rated 30 or 32 amps to protect your cooker unit. The second example, this one you can do it on your own. That is example 2. A cooker unit has a full load rating of 11 kilowatts at 230 volts. Calculate the current rating of the cooker if the cooker unit has a socket outlet embedded on it. That is your homework. Please try to compute that. Let me repeat. A cooker unit has a full load rating of 11 kilowatts at 240 volts. Calculate the current rating of the cooker if the cooker unit has a socket outlet embedded on it. Thank you.